Okay, time to find area under a curve, or sometimes it's over the curve, depends on what we're asked for. All right, so here's our question. Find the area enclosed between the x-axis, the curve y equals x squared minus 4x plus 3, and the lines x equals 1 and x equals 4. So first we're going to do this problem with the calculator, and then we're going to do it again without the calculator. So you can see the two different approaches. So with the calculator, we're going to do first. So with the calculator, the first thing you want to do is enter the equation into your calculator and make a sketch of the graph. We want to see what it looks like. Okay, so get my calculator. And I'm going to go to y equals. Let's get the glare off of it. And I'm going to type in x squared minus 4x plus 3. And let's graph it. And then we want to make a sketch. What did I do with my straight edge? There it is. Okay, so I'm going to sketch my graph. Because what we're interested in is we need to see what part of the curve is above the x-axis and which part is below. Because as we discovered on our worksheet where we started doing these problems, is that the part above the x-axis will give me a positive area, but the part below the x-axis will give me a negative area. But if I want the total area, I need to change any areas that are below the x-axis. I need to make them positive. Okay, so we're going to go ahead and graph this. So I can tell by looking at this, I know it has a y-intercept of 3. You always want to get your important points on here. My y-intercept is at 3. Again, I could put in 0 for my x's, and that would leave me with 3. So 0, 3 is my y-intercept. And it looks like my x-intercepts are at 1 and at 3. I could actually figure that out exactly by doing second calculate and then finding my zeros. So I could go and I could find my zeros. So if I went this one right here, left bound, then go to the right of it, hit enter again, hit enter, and it tells me x is 1. So there's one of my x-intercepts. Then I can do that again, go to zeros, the second option there, and I want to go over to the other x-intercept, left side of it, move to the right side of it, and hit enter again, and it tells me at 3. So my x-intercepts are at 1 and 3, and I can figure that out on my calculator. So now I'm going to sketch it. There it is. And I'm interested in finding the area enclosed between the x-axis and the curve between the lines x is 1. So here's 1, and x is 4. So 1, 2, 3, 4. So from here to here. So I'm going to shade this in. So anywhere between the curve and the x-axis, here's my x equals 1, here is my x equals 4. So if I shade that in, I want any areas that are bounded by this curve and the x-axis. So that would be this area right here is bounded by the curve and the x-axis, and this area over here is bounded by the curve and the x-axis, and it's between the 4 and the 1. So notice there's two areas here. So as we noticed in class, the part that is below the x-axis, if we were just trying to find that area, we would end up with a negative answer because it's below the x-axis. And this part over here, we'd end up with a positive area. So we need to take these two areas separately, because if we try and do them together, the negative is going to subtract off the positive, and we might actually end up with a negative answer, which we don't want to do. So we want to notice where the parts of the curve are below the x-axis. Okay, so this is going to give us positive, but this down here would give us a negative area. Okay, so that's what we're looking for. So notice which parts would be positive and which are negative? Okay, so this part would give me positive, this would be negative, this is negative because it's below the x-axis. So what we need to do is we're going to have to integrate this problem separately from here to here and from here to here. We're going to have to set up, so we need to find the boundaries for the negative area and we need to find the boundaries for the positive area. So we're going to find the boundaries. And we actually did that using our graphing calculator by finding the x-intercepts. So we know that between 1 and 3, that's where it's the negative. Okay, so we are going to find the boundaries for the negative area, and we're going to evaluate the integrals between there, but then when we get the answer, we're going to make it positive. Okay, so one thing you can think about on this, if I just took a little close-up of this spot right here, so I'll do a little close-up right here. So if I have this little negative area, so like that, that's my little negative area, let's say that. This area, these points right here are my f of x. Okay, so f of x, my equation is giving me this curve right here. And what I want is I want all these y values to be up here. So I want to flip these. These right now, my y values are all negative, but I want to flip it. I want it to be up here so that all of my y values are positive. I want to flip it. So if this is f of x and it's giving me negative y values, to make them positive, I would need the absolute value of those y values. That would give me positive. So I want to take all these negative values and I want to flip them so they're on top so I get positive values. So the way we show that is I can set up my integral. I want to take the absolute value of my y values and I want to integrate it, and I only need to make it the absolute value from 1 to 3. Okay? So then from 3 to 4, that one's just fine. So I'm going to find that area and I'm going to add it to the one that had the negative answer. So I'm going to find the absolute value of the answer for the 1 to 3, and then I'm going to add that to the other part where the area is positive. So that's from 3 to 4. So that's just regular f of x dx. I don't need to worry about taking the absolute value. So the part that would have been negative, I need to evaluate that, but I need to take its absolute value. And then the part that was already positive, I don't worry about it. I'm just going to find it. Okay, so on my calculator, I'm going to go ahead and figure out what these are. So I'm going to put this into my calculator. So I am going to go second calculate, and number 7, I'm going to put in my boundaries. 1 is my lower limit. My upper limit is 3. Hit enter. And it tells me the answer is negative 1.333, but I already told you I'm going to take the absolute value of that, so I'm just going to write down 1 and 1/3. So this area right here was negative 1 and 1/3 according to the calculator, but I'm going to take its absolute value. I'm going to take it as if all the y values were positive, and so that gives me 1 and 1/3. Then I'm going to do this part over here, which is positive. So go to 7, and this time I'm evaluating from 3 to 4. So my lower limit is 3, my upper limit is 4, and it tells me, oh, that area is 1 1/3 also. How convenient. So this area is also 1 1/3. And then I can add those together to get my total area. So 1 1/3 plus 1 1/3 is equal to 2 and 2/3. And since it's an area, we can go ahead and put some units on it. That would be units squared, or just u squared would be fine. Okay, so when you're using your calculator, this is pretty straightforward. You can just bust it up, look at where your negative and positive intervals, areas, and then make sure that you change any negative areas, change them to positive after you found their values. Okay, there actually is another function on the graphing calculator that can allow you to do this whole thing in one fell swoop, but it's easy to forget. and it's not very helpful if you don't have a calculator. So I'm going to show you that in class. I'm not going to put it into the notes. I'll show you another shortcut on the calculator in class. But this is kind of the classic way of doing it, is break it up into different areas and then find each individual area. Any negative areas, make them positive, and then add them together to get the total area. Okay, so now we're going to do the same problem again, but we're going to do it by hand. Okay, so I'm going to turn the page, and I'm going to do the same thing, but without a calculator. So, without a calculator. So, without a calculator, of course, it's significantly harder. It's the same question, and we also want to start by sketching a graph. So, we know that we have y equals x squared minus 4x plus 3, and we know that our boundaries are going to be x equals 1 and x equals 4. So I'm not copying over the entire verbiage of the problem, but it is the exact same problem. So imagine I had copied over the whole problem, but this is really the information that I need. So how do we graph this? Well, I happen to know this is a parabola. So how am I going to graph this parabola? Well, I know the y-intercept is 3. So I have my y-intercept is equal to 3. And then I could find the vertex by using the vertex formula, or I could find the x-intercepts by factorizing this. So I think I'm going to factorize this. I'm going to let this be equal to 0 is equal to x squared minus 4x plus 3 to find my x-intercepts. So 0 is equal to, this would be x times x. To get a 3, the only way I can get a 3 is 3 times 1. To get a negative here but a positive here, both of these are going to have to be negative. Does that work? Negative 3x plus negative 1x. Yay, it works. Okay, so now I can get my x-intercepts by setting each of these equal to 0. And I get x equals 3 and x equals 1. Okay, so as you can see, doing it without a calculator is already way more work than with a calculator. So there's a reasons why we have calculators. All right, so let's go ahead and graph this puppy. We know it's a parabola, and we now have the x and y intercepts, so it should be pretty easy to graph. And also, since we already did this problem with the calculator, we already know what it should look like, but we're pretending like we don't know. Okay, my y-intercept is 3. My x-intercepts are 1 and 3. And then I'm just going to sketch in my parabola. Okay, and then it says that I need to find the area between 1 and 4. So here is 1, 2, 3, 4. Here's 4. So this is x equals 1 and x equals 4. And we want to shade in the area between the x-axis and the curve. So that would be here and here. Okay, so now we're kind of back to where we were when we did it with a calculator, but this time we did all the graphing without a calculator. Okay, so remember, we're not using our calculator. So just like we did before, we want to notice which parts would give us a negative area and which parts would give us a positive area. And we want to integrate those separately. So the first part here is from 0 to x equals 1 to x equals 3. So I'm going to set up my integral from 1 to 3. And all the little rectangles in here, they would have a height of f of x, and they'd have a width of dx. And then the second part over here, which I would add to it, it's going to be from 3 to 4, and each of these rectangles would have a height of f of x times the width of dx. Okay, this one, since it was negative, remember we're going to take the absolute value of it. So that's how we show that. That's the notation that we use to show that we're going to take the absolute value of this one, because we know this is the negative area. This was the negative area, so we're going to take the absolute value of it. And this was the positive area. And we just need to do that normal. All right, so what is my f of x? It's right here. So we're going to integrate these. So 1 to 3. F of x is x squared minus 4x plus 3 dx. And this is pretty straightforward. I don't need any u substitution. I'm just going to use my power rule. So I add 1 to my exponent and multiply by the reciprocal. Same with the next one. Add 1 to my exponent. There's an invisible 1, so that becomes x squared. Keep my 4, times that by 1 over my exponent, plus add 1 to my exponent. Well, it doesn't have 1, so that's x to the 0. Add 1, that becomes 3x. Okay, and I'm going to evaluate that from 1 up to 3. Okay, and then I'm going to add that to the other one. So the other one is going to be from 3 up to 4, same function, x squared minus 4x plus 3 dx. When I take the antiderivative, I get the exact same thing here, so I don't have to think so hard. I can just copy it down. So that's going to be 1/3 x cubed. I'm going to go ahead and simplify this when I copy it over here. 4 times 1/2 is 2, so minus 2x squared plus 3x. That's going to get evaluated from 3 to 4. Okay, so now I'm going to go ahead and do my substitution. So I'm going to start with my upper boundary. Oh, and remember, we're going to take the absolute value of this. So I can put my absolute value bars. I'm going to take the absolute value of this after I evaluate it. Okay. So I'm going to go ahead and do my substitution. I'm going to have 1/3 times x is 3 cubed, minus 2, because 4 times 1/2 is 2, times 3 squared, plus 3 times 3. Now, I'll show you something interesting. This is going to get repeated over here for the lower boundary. Okay, so once we simplify this, we can just copy this answer over to this side. All right, now we're going to have to subtract from that, and I probably should have been writing smaller. I'm going to take up too much space. So let's start writing smaller. 1/3 times 1 cubed minus 2 times 1 squared plus 3 times 1. Okay, so that's all of this, and we're going to be taking the absolute value of that. That should give me a negative value. Okay, so let's go ahead and finish this. 3 to the 3rd divided by 3 is the same as 3 squared, so this is just 9. Just that. 3 squared is 9. 9 times 2, so negative 18, plus 9. So 9 plus 9 is 18, minus 18, oh, that's just 0. Okay, so this is going to be 0. All right, and then this part, 1 cubed is 1. 1 times 1/3 is 1/3. Notice I'm not dropping my parentheses yet. 1 squared is 1. 1 times 2 is 2, so minus 2. 3 times 1 is 3. Okay, minus, let's see, negative 2 plus 3 is 1. 1 plus 1/3 is 1 1/3. 0 minus 1 1/3 is negative 1 1/3, but then we're taking the absolute value, so this ends up being 1 1/3. So this area right here is 1 1/3. Oops, can't see what I'm pointing at. This area underneath the curve here, our negative area, is 1 1/3. Okay, now I'm going to do the other one over here. So I'm running out of room a little bit, so by the way, I forgot to put my plus sign there. We're going to go ahead and evaluate it at 4, and then to evaluate it at 3, I already have that answer. I already did it. I know that's 0, so I'm just going to borrow that from over here. So I'm going to move this one. I'm going to kind of skip a line. I'm going to put it down here. I'm not going to put it right here because I've run out of room. So plus, now this one is going to be with the 4, so 1/3 times 4 cubed minus 2 times 4 squared plus 3 times 4, and minus, evaluated with the lower boundary with a 3. I happen to know, I already did that one, that actually is just equal to 0. So I'm just copying that over. Okay, so you don't have to like redo it again. Okay, so that's, this problem is right here. So this is with the upper boundary, the 4. This is the lower boundary with the 3, which I had already simplified that and figured out that that was 0. Okay, so let's go ahead and take care of this. So plus 4 times 4 is 16, times 4 is 64, so I have 64 over 3. I'm not going to worry about simplifying that yet. Then 4 squared is 16. 16 times 2 is 32, so minus 32. Plus 3 times 4. 3 times 4 is 12. And now negative 32 plus 12. I have my 64 thirds. Negative 32 plus 12, that is negative 20. Okay, at this point, I think I'm going to make this into an improper fraction. Let's see what happens if I do that. 3 goes into 64, 21 and 1/3 minus 20. So 21 and a half minus 20 leaves me with 1 and a half. So I still have my 1 1/3 from the absolute value of the negative portion, and I have 1 and, oops, sorry, that was 1 1/3. 1 1/3, eek. Sorry. Why did I change my denominator? That's silly. So 1 1/3. 1 1/3 plus 1 1/3 is equal to 2 2/3. So was that the answer that I got before? I don't even remember. What did I get before? Oh, 2 2/3. Did it work? Oh, thank God. I didn't want to have to do these notes over again. Units squared. All right, so clearly doing this with a calculator is way easier than doing it by hand, but it certainly is possible to do it by hand. And so tomorrow in class, we're going to be working with even fancier looking areas, even fancier than this, but we'll be doing a lot of it with the graphing calculator so that we can make sure that really it's how do we set up the problem. That is really where all the thinking happens. All the rest of this is just can you deal with mathematical rules. So what's really important is can you think how to set up a problem. Okay, and I'll also show you a shortcut on how to do this on the calculator for those of you who like calculator shortcuts. But the main thing I'm interested in is can you set up the problem? Can you set up the problem, think your way through it to make sure that you get all the area accounted for. So that means taking any negative areas and taking their absolute values. Okay, see you tomorrow.